So we've talked about exponents and their properties. Today we're going to talk about rational exponents. So just a reminder, rational essentially means a fraction. So rational exponents means sometimes exponents can be fractions. So for any real numbers a and b and any positive integer n, if a to the n equals b, a is the nth root of b. Now, I know this is just math gobbledygook, doesn't make a lot of sense, but I think if you look at these examples, it'll make more sense. So you've learned about square roots before. So the square root of b is the same thing as b to the 1/2. We call that the square root. So rational exponents are really just a way to write roots as exponents. So just as the square root can be written as 1/2, the cube root can be written as an exponent of 1/3. Now these are exactly identical to each other. They're just two different ways to write the same thing. Now there's reasons sometimes it's easier to write one over the other, which is why they did this, but they literally are the same thing. Then the last is just the general one, the nth root. So just like with exponents, we say squared and cubed. We have special names for square root and cube root, but after that it's the 4th root, the 5th root, the 6th root, and so on. So on this first set of questions, we're not computing or evaluating anything. We are only trying to rewrite them in a different form. So as we see right up here, an exponent of 1/2 is the same thing as the square root. So 25 to the 1/2 is the same thing as the square root of 25. And we can take it both directions. A square root is the same thing as an exponent of 1/2, so we can write 18 to the 1/2 power. And that's the same as the square root of 18. Now, here's where you have to be careful. On number 3, the exponent of 1/2 is the same as the square root, but you have to pay attention to what that exponent is actually applying to. 5 is not being raised to the 1/2 power. Only the x is. So 5 stays exactly like it is, but the x can go under a square root. Now 4, both the 8 and the p are under the square root. So since both 8 and p are inside the square root, we should put both 8 and p in parentheses and write it as an exponent of 1/2. Because on this one, the 8 was under the root. So the 8 should be applying, or the exponent should apply to the 8. Whereas here, the exponent did not apply to 5, so the root should not either. Okay. Now on these, we are going to evaluate some. So there will be some times I ask you to do these things without a calculator. Now essentially, you'll just have to know a few numbers and their powers. But you may have to get to know them. Most of the time, I'll only expect you to know the square roots. But for 2 and 3 and maybe 4, I may expect you to know bigger ones, just mostly the cube root, but you'll see examples soon. So 49 to the 1/2 is the same as the square root of 49. Now you don't have to write that step. If you're able to understand that without writing it, that's totally fine. But remember, the square root means what number multiplied by itself equals 49. Well, that would be 7, because 7 times 7 equals 49. Okay, now here's where we use the power properties we learned before. So everything inside here is being raised to the 1/3. So 1 raised to any power is just 1, so that doesn't change. 27, I'm going to write it this way. 27 raised to the 1/3. That's the same thing as the cube root of 27. So the cube root says what multiplied by itself 3 times would equal 27. And that would be 3. Then, just like we learned before, when we have an exponent raised to an exponent, we multiply those numbers together. So 3 times 1/3 is 1, so we just end up with x to the first power. And if you want to write a 1 for the power, you can, but you don't have to. Here on number 7, we need to apply this 1/2 exponent to everything inside. So 16 to the 1/2 is the same as the square root of 16, which is 4. But here we apply the property that says if we have an exponent raised to an exponent, we multiply them. 2 times 1/2 is 1, so x to the first. 4 times 1/2 is 2, so it's y squared. Okay, here's some bigger ones. So you got to think, okay, what cubed? So you can start just going up. So you think like, okay, 2 times 2 times 2, that's 8. 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. 5 times 5 times 5. 5 times 5 is 25, times 5 is 125. Whew, getting big here. 6 times 6 times 6. 6 times 6 is 36. 36 times 6 is 216. So it turns out that the number that multiplies by itself 3 times equal 216 is 6. Okay, fourth power here. Okay, 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. 3 times 3 times 3 times 3. And I'm doing 4 because I know some number multiplied by itself 4 times must equal 256. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 4 times 4 times 4 times 4. All right, 4 times 4 is 16. 16 times 4 is 64. 64 times 4, lo and behold, it's 256. So the fourth root, or the 1/4 power of 256, is 4. Okay, fifth power, each. 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So I just did all that. Man, sorry, now I feel like the foolish one. I didn't read my own directions. These you can do with a calculator. So, let me pull out the calculator. See if I can get mine up. Hold on just a second. Okay, here we go. I think I can, yeah, this one looks more like yours. It's not exactly like yours. So to do this in the calculator, mine right here has a cube root button, but you can also use this. So the y represents whatever root you want, so I could type in 3, then this, so it's taking, oh, okay, I did it backwards. I'll show you on your calculator for sure when we do this in class. So I type in this, 216, and then 3. So it's the cube root of 216, which is 6. Now, another way you can do it is remembering that this is the same as 216 to the 1/3 power. So I have 216, and then in your calculator has that little caret button, looks like an arrow pointing up, and then you would type in parentheses 1/3. I can do that similar here. I do this, and then parentheses 1/3. You gotta make sure you're doing parentheses or else it'll just raise it to the first power, then multiply the answer by 3. So this one we get 256 to the 1/4, so 256, and here's this little caret button. The caret button looks like this. It's right above your squared button, which is right next to your 7. So you would press the caret button and then do parentheses 1/3. Or excuse me, 1/4 on this one. And you get the 4. Okay, and then on this one, 32 raised to the 1/5. We get the 2. Okay, so smaller ones like we had up here, I will expect you to know to do in your head. how to do it in your head. But bigger numbers like this, I'll expect you to know how to use your calculator to find it. Okay. For any positive real number b and any integers m and n that are greater than 1, we can also do a fractional exponent or rational exponent where 1 is not the numerator. Because if you look back, everything we did on the front when we had a fraction, we had a 1 on top. Had a 1 on top every time. Now we had different denominators, 2, 3, 4, 5, but we always had a 1 on top. So this side is just showing us how we can actually have numbers on both the top and the bottom, numbers other than 1, I should say, on both the top and the bottom. So here's what you need to know. The number on top is the exponent. It's what we often call the power. The number on the bottom is the root. So you can see here, they changed this m to be an exponent. They changed this n to be a root. And it doesn't matter whether you write it as the nth root raised to the m power or the nth root of the m power, because the order we do these things in doesn't matter. So for example, down here, they rewrote 8 to the 2/3 as the cube root of 8 squared. So they first took the cube root of 8 and got 2, and then said 2 squared, which is 4. And that's completely fine. But you could also get the correct answer by saying 8 squared is 64, and the cube root of 64 is 4. So you can do it in either order. You could say, all right, I'll do 8 squared, and then I'll cube root that. Or you could say, I'll cube root 8, then square that. So the order can go either way. Okay, so simplify, they mean rewrite it in a root and exponent form. So again, this is a squared, this is a cube root. One way I try to tell students remember it is, technically a power is the whole thing. So technically a power is this entire thing. But we usually say just this is the power, the exponent. So if you think of the exponent as power, the things that are in power are on top. Just in the world, things that have greater power are on top. But what's underneath the ground of a tree is its root. So the roots are the basis, the foundation, the things underneath. But the thing that has power rises at the top. So that can be one way you remember which one is which. So I can rewrite this as the cube root of 64 squared. Or if you wanted, you could write it as the cube root of 64 squared. Either one of those is fine. You don't have to write both. And this is one reason that I think the fractional or rational exponents are helpful, because it's honestly a whole lot easier in the calculator to just type in an exponent of 2/3 than it is to figure out how to type this in. You can do it, it's just a lot harder. So 64 raised to the 2/3 is 16. And this is where it's actually helpful if you ever have to do it in your head, which you don't on this one. But it's nice you can do it in either order, because even for me, 64 squared, that does not jump out at me as something I remember. I could probably figure it out with a little bit of time, but I'm not gonna. However, I do know the cube root of 64 is 4. So if I do that first, I get myself to a smaller number. Cube root of 64 is 4, and 4 squared is 16. Okay, this one we'll first rewrite it. So remember, the 5 is an exponent, and the 4 is a root. And we can plug this in the calculator. 256 raised to the 5/4 is 1024. Okay, last thing. For any real number where b is greater than 0 and b is not 1, it can only be true that two things would have the same base. That's why they use b in both of these. Now it can be any base. It could be 7 and 7. It could be 11 and 11. It could be 40 and 40. But the point is, if the bases are the same, and these two things are set equal to each other, the only way this can be true is if the exponents are all also the same, which I think if you look at this example, it makes pretty good sense. If I tell you 5 to the x equals 5 to the third, well then x must be 3. That's the only way these two match. And if we have 4 to the n equals 4 to the 1/2, then n must be equal to 1/2. So what we have to do sometimes though is get it to where these have the same base. So once you have the bases the same, this is very easy. You just set the two exponents equal to each other and you're done. But they often won't start as the same base. So you see here it had 6 to the x equals 216. You're like, well, that's two very different bases, and you're right. That's a 6, that's a 216. However, 216 can be written as 6 cubed. And now that they have the same bases, it's very easy. We say, well, if the bases are the same, the exponents must also be the same. So x is equal to 3. Okay, now on number 1, we have 25 and 5. So we think, all right, 25 is the same thing as 5 squared. And if it helps, you can remember that if there's no exponent written, it's an understood exponent of 1. So we can remember our properties that we learned in the past couple lessons. If an exponent is raised to an exponent, we can multiply those two exponents together. So 2 times x is 2x, 2 times 1 is 2. So now that we have all that sorted out, we see the bases are the same, 5 and 5. We know the only way this can be true is if the two exponents are equal to each other. So we set 2x minus 2 equal to 1 and solve for x. So I add 2 to both sides, divide both sides by 2, and I get x equals 3/2 or 1.5. Okay, next up, 5 to the x equals 125. So task number 1 is to get the bases to be the same. So 5 is already a prime number. I can't break it down any farther. But 125 is the same as 5 cubed. So I have an x and a 3. They have to be equal to each other. So x is equal to 3. Number 3, we have a 12. There's nothing raised to a power that equals 12, so it just stays as it is. It's not prime, but there's no number that you can square or cube to get 12. But 144 is 12 squared. So now that the bases are the same, we can set the two exponents equal to each other and solve for x. Subtract 3 from both sides and divide both sides by 2. So we find out that x equals -1/2.